Right, yeah, that's not gonna work. All right, so we're gonna do exponential model. Remember me bringing up PERT, like, from pre-calc that we did? This is basically gonna be almost a pre-calculus lesson instead of a calculus lesson. So the way it's gonna be worded though, and this is the wording that you have to get used to, it's gonna say the rate of change, which hopefully that should trigger in your mind derivative, the rate of change of a quantity, and they're gonna make it be a story about something, like an amount of stuff, is proportional to the size of the quantity. So the way that's going to look is dy dt. So that's your rate of change. And sometimes they won't make it y. They'll make it a letter that corresponds to whatever the thing is that they're talking about. Okay. Dy dt equals k times y. Is proportional to just means that you've scaled it by something. So you would have like 2y or 7y or 8y. Do you get what I'm saying? Like k would just be your scaling by that amount. But you have to get used to this wording because that's what the problem is going to say. When you see that wording, you want to think PERT. Okay. So, but I'm going to take you through it. We're going to, for number one, we're going to do all the whole everything for the steps. So it says the rate of growth of bacteria is proportional to the number of bacteria present. The way that's going to look is dy dt. I'm using y for bacteria. You could use b if you wanted, but I'm just going to go with y. Equals k times y. Actually, I don't know why I just rewrote that. It's the same thing that we have right there, but whatever. I just copied it. So we're going to solve that just like you did on your quiz. So what would you do to separate the variables? How would you move over the y? Yeah, divide it. So it's going to be 1 over y. Now, if it was y squared or y to the 5th or y to the something, how would you write it instead? Negative exponent. Good. This is the only one that like doesn't follow that. dy equals k dt. And then we're going to do our antiderivative. So what's your antiderivative for 1 over y? So ln y equals, now this is a little tricky. It's like we're trying to jam every letter of the alphabet into this problem. You're doing this antiderivative with respect to t. So does anyone want to give it a try? Kt plus c. It really is like every letter of the alphabet. And there's about to be another letter that we put in there because how do you get rid of ln? E. All right, so it's y equals c e to the power kt. We don't usually put the plus minus in front of this one because usually it's word problems and you don't have negative quantities of stuff, but it's PERT. It's just now it's kakect. Okay. But do you remember how in pre-calc I just told you it's PERT? We just went through why it's PERT and where that comes from. But you have to know how to do an antiderivative in order to do that. So I can't explain that in pre-calc, but now you know that's where that comes from. Okay. So that's your equation. C is your initial amount. And what does initial mean? Starting, so your initial condition, in other words. K is your rate. That's why in PERT, R stands for rate. T is time. You can label that if you want, but I'm pretty sure you know that. And then like Y is the amount. Like that's the thing that you're talking about. So like in this problem, that's going to be the amount of bacteria. That's like what you've got. In pre-calc, we did this with money. Do you remember you put money in an account and then P was the principal? Like that's what you end up with, or like the principal is what you start with. And then we use A, I think, for amount, what you end up with. Anyway, it's the same thing with different letters of the alphabet. So let's put some actual numbers in there. There's 300 bacteria present initially. So it's going to be Y equals 300 e to the power kt. And it says there's 700 bacteria 10 minutes later. So where are we going to put the 700 in for? Y is your 700. And then 10 gets plugged in for t, which is time. And now we're going to solve it. So what would you do to start solving for k? K is the thing we're missing. We need the rate. Yeah, get k by itself. So what would you do to both sides? Now, 700 divided by 300, the 7/3 equals e to the power 10k. And then you want to cancel out e, so you would do ln, and I would put some parentheses around that 7/3. When you do it in the calculator, it's going to put parentheses there anyway. So ln 7/3 equals 10k. And then what would you do to get k? Okay, so here's what I want you to do. In your calculator, you're gonna type ln 7/3 divided by 10. And you're gonna get a wacky decimal, but everybody go ahead and do that. ln 7/3 divided by 10. I did it in 2 steps. You could also just write divided by 10. I don't know. I just always hit enter when I'm doing that. You could also use alpha y equals and put it in a fancy fraction bar. However you do it. Did you get 0.84 or 0.084, excuse me? Okay. Store alpha A, enter. Store alpha A, enter. Store alpha A, enter. We're going to use that. But when you're taking the AP exam, you need, like, your grader can't tell what happened in your calculator, so you're going to have to write that. It's going to be 0.084, and then just put arrow A to show that you stored that as A, and then they'll know. So it said write an equation. We found the rate, that K value, so your official final answer would be y equals 300 e to the power 0.084 t. That's like your equation. Sometimes they ask you for the K value, sometimes they ask you for the equation, and sometimes they ask you to actually plug something in, which is that last part there. So you just have to read the directions. Use that equation to predict the number of bacteria after 20 minutes. Well, what are you going to do with 20? Plug it in for time. So what I would like for you to all do in your calculator is type 300 e to the power. Now don't type 0.084. You should type what? Yeah, alpha A times 20 minutes. And that gives you your answer. Although I messed up. I was going to say that doesn't seem right. What did I do wrong? I put 30 instead of 300. Let me go put another 0 in there. I was like, hey, wait, that does not seem like enough. There we go. So 1,633 and 3 repeating bacteria. We can decimal point a bacteria because I don't feel bad for them. All right. Rate of change of a certain population is proportional to the population. When you read that, you want to think PERT. The rate of change of the population is proportional to the population. So think PERT or CACECT, all right? At time 0 years, so that's initially, the population is 500 people. So it's going to start out looking like this. 500 is how many we started out with. And actually, I'm going to show you how to work through this one without the calculator because I have seen multiple choice questions. And I think there's one on your AP assignment that makes you go through it without the calculator. So I'm going to show you how to do this one without it. At time 4 years, the population is 750. Where am I going to put each of those numbers? Yeah, 4 is T and 750 is Y. And then you solve it for K. K is the thing that you're missing. So you would divide over the 500. That would reduce down to 75 over 50, which what would that reduce down to? 3 over 2, 3 halves. So 3 halves equals e to the 4k, then what? ln, so ln 3 halves equals 4k. Divide by 4. Don't reach for your calculator. I'm going to show you how to do this one without it. Again, because I've seen multiple choice ones like that, which is cool because you just don't have to type anything, just leave it like that. All right, now it says, at what time? So this is actually kind of backwards. We want time that the population was 600 people. So we're going to kind of start over, go back to the original equation. Where would I put the 600 in for? Y is 600. We want that to be the amount equals 500 e to the power. All right, what did we find for K? I know it's kind of a mess, but that thing, good. ln 3 halves over 4 times T. And then you have to unbury the T. You're trying to get T by itself. I promise it won't be as bad as you think it is, though. What would you do to start solving for T? Good, so 600 divided by 500. So 6/5 equals e to the, that. And then ln, good. You guys all had wonderful pre-calculus teachers. You know what's going on. And I realize that this part looks like a disaster. But when you have a fraction, do you see how it's a fraction? ln of stuff over 4. You multiply by the reciprocal. So what we're going to do is multiply by 4 over ln 3 halves. So if you multiply on this side by 4 over ln 3/2, it's going to look like this. So we have our ln 6/5. I just multiplied by 4 over ln 3/2, and that's our time. And that's the answer. And in the I saw a multiple choice one that looked like that. The answer looks like that. And what would it be? Years? Was it? Yeah, whatever, years. It's time. Let me be not lazy. I'll put years in there. We'll be able to finish this before lunch. This goes really quick. All right, doubling time and half-life. Doubling time is time for the initial amount to be twice as much. It's exactly what it sounds like. And half-life is the time for the initial amount to be half as much. You encounter the half-life stuff in chemistry a lot. You talk about like the element that breaks down or whatever. I don't actually know what I'm talking about there. Doubling time, people remember that's a time because the word time is literally in there. The only thing is with half-life, people forget that it's a time. So just try to remember it's the thing that's T, that's time, okay? So an element has a half-life of 1,500 years. If you're like, wow, that's a long time. Yeah, it takes a long time for stuff to like biodegrade, right? An initial amount of 200 grams, find the amount after 10,000 years. I would start with this. The initial amount is 200. So it's y equals 200 e to the kt, like think PERT. And if you have half as much as what you started with, how much have you got? If you started with 200, now you have 100. It didn't come out and say that in the problem, but half of 200 is 100. So 100 is your amount that you ended up with. And then what else can I plug in? The years is 1,500. So when you start solving that, what do you get on the left side? Oh my gosh, that's crazy. Why on earth is it a half? A half-life. So a lot of people will actually skip this and jump straight to that step, which is honestly fun. They're like, oh, half-life, it's going to be a 1/2. All right, then what? Yeah. ln. And I'm going to go ahead and tell you to just write it as ln 1/2 over 1,500. Because if you type that into the calculator, it's such a tiny decimal, it's going to put it into scientific notation. Do you remember blah, blah, blah times 10 to the negative whatever? It looks like a mess in the calculator, so just leave it like that, okay? Now it says find the amount after 10,000 years. So we're going to start back over with our original equation. It's going to be 200 e to the power this ln 1/2 over 1,500 times 10,000 for our time. And that you can go ahead and put in the calculator. Just be really careful because it's kind of a mess to have to type. Just in the exponent, this right there. Because the t, it's e to the power k times t. So the k times t is all within the exponent. I just had to write it kind of big because it was a lot. But if you want to look at mine, do you see how I'm writing it like literally exactly like it looks on my paper? Did anyone get the same thing as me? Yes, I got. And does that answer make sense? Oh, yeah. Yeah, I mean, after 10,000 years, you're not going to have much left. I'm going to skip number 4. It's the exact same thing except with a doubling time. So instead of a 1/2 on this side, what would you end up with? A 2. And then you would go through and do the whole thing in your calculator. Let's just do the last one there because I only have a couple more minutes before seniors are going to leave for lunch here. All right, sales of TVs in thousands. Oh, my pencil broke. I'm going to have to switch to a pen. Being risky here. Sales of TVs in thousands follows this equation. Now, if they give you an equation, don't change it to PERT. Just go with what they gave you. 10,000 TVs are sold in 1 year. Now it says the saturation point for the market is 50,000 TVs. What that means is you're going to saturate the market with TVs. TVs aren't like toothpaste and deodorant and toilet paper, things that you buy over and over and over again continually. Once you have a TV, usually you're pretty set for a good long time. Do you get what I'm saying? So if you're a TV salesperson, once you sell enough TVs, you're not going to be able to sell anymore because you saturated the market. Do you get what I'm saying? Yeah. Okay, that's a limit. I hope it feels like a limit to you because it's a limit as time goes to infinity of this equation is going to equal not 50,000, but 50. Why is it just 50? Because it's in thousands, okay? Now look, I'm going to just talk you through this. If time gets bigger and bigger and bigger and bigger and bigger and bigger, remember this from unit 1. If the denominator gets astronomically large, you end up with something like 1/1,000,000th, which is like 0. So this part goes to 0. What is e to anything to the 0 is 1 times c is just c. So c is 50. You saturate the market at 50. So we've got s equals 50 e to the k over t. Then from there, it's smooth sailing. Now you plug and chug. Read the question and tell me what I can plug in where. It says 1 year, so 1 for time, and then it's S, but it's not 10,000, it'll just be 10. Good. And this will actually just be e to the k, because if it's 1 year, k over 1 is just k. I can do this in 1 minute. I can do it before the seniors leave. All right, what's going to happen? What are we going to do? 1/5 equals e to the k. ln, don't bother typing it in. How many TVs get sold in 3 years? You're going to come back to this original equation. S equals 50 e to the power, that thing, ln of 1/5 over 3. Slam that in your calculator. You're going to get the number of TVs. Seniors, just humor me for 1 second. Like, let's just finish this problem and then we'll be done with it. You'll still get to leave a second early. What is it? ln 1/5 divided by 3. Now it's not 29 TVs. It's actually 240 TVs. Because remember, it was in thousands.